Next team is the learning track. Customer is Professor Bennett Goldberg here. And this is an interesting system that deals with the whole issue of new techniques for teaching. So they built a system which they'll talk about. So the next team, Team 10, the learning track.
Good morning. I'm Jillian, and here's Katsu, Dickson, and Xiang, and together we make up the track team, the developers of the Learning Track iPad application for Professor Bennett Goldberg. Today, professors have a lot of different student grades and grade sheets, but it's really hard to evaluate a student's performance off of raw numbers. As the class gets larger, it becomes increasingly difficult to do so. We've developed the Learning Track to solve this problem by giving them a visual display of student performance.
So for our project, our front-end application will be running on the iOS platform, and the back-end will be running on a Java web application on Ubuntu. For our iPad app, we wanted to provide a single project that would be compatible across multiple platforms, such as iOS, Android, and Windows. However, the traditional approach to mobile development meant that you have to use native development tools and languages for each respective platform. This requires the management of different projects and code, which is both costly and complex to maintain. Our solution to this was using Xamarin's Touch and to develop our application. Touch is an application programming interface, otherwise known as an API, that allows developers to create C# and .NET-based applications to run on the iOS platform. Additionally, Touch has the ability to port code onto different platforms, which addresses our initial concern and allows our application to be cross-platform. Our decision to develop on Touch was ultimately influenced by our experience and familiarity with C# writing.
For a back-end development platform, we're just creating a Java web application that runs on our Apache Tomcat server. We're just running on a simple VM for right now to show a proof of concept of our work. So going into more specific detail about the backend, there's three main parts, modules that the backend has to, the backend contains. The first is the RESTful web service. I'll go into each of these parts in more detail later, but there's a RESTful web service that communicates with the iPad. The second part is a SOAP client that communicates with a Blackboard server. And the third part is a Postgres database where we store seating chart data. So we'll see that here the iPad is not directly communicating with the Blackboard web service. So instead we opted to do a proxy server in the middle. This is because the iPad can support specific SOAP WS security libraries in order to communicate with Blackboard web service. So the RESTful web service that we provide on our proxy server, or backend, is just an endpoint for communication for the iPad. And the iPad will directly send requests to this RESTful web service, requesting data, assignment info, course grade, and course listings. And then it'll take those requests and channel them to the second part, which is the SOAP client. Because we put this on a proxy server, ISMT was able to provide us a wrapper around our RESTful URLs so that we could log in through view web login, get authenticated, and their wrapper would inject the URL, would inject the usernames into the URLs. So after the proxy server received the requests from the iPad, we then take those requests and format them into SOAP messages that we can send to the Blackboard web service. The Blackboard web service, for it to work, we need to register something called a proxy tool, which allows us to credentials and our requested services from Blackboard, like do you want to be able to access the gradebook, do you want to see student information. So the SOAP client just handles our communication with Blackboard web service. And once the information is returned to the SOAP client on a proxy server, we can then send it back through the RESTful endpoints that we talked about earlier. And thirdly, we have a database just to store seating chart data because we want to be able to have, store where students are sitting during in a course, right? So that when we click on them in the iPad application, we can see their grades and such. So we opted for having this database stored on the proxy server rather than having data stored on the Blackboard web service. So what this database allows us to handle is just simple integrity constraints so that multiple students can't sit in the same seat, a student can't sit in multiple seats in the classroom.
So this is the initial view. The user can begin by pressing on the View Web Login button, and that will launch this window, where the user will then be prompted to log in using their login credentials. As a side note, as Katsu previously mentioned, security was a major concern for our project, and the authentication process was a collaborative effort with BU's Information Services and Technology Department. They provided us with code to authenticate the user as well as a backend to support those authentication requests. So continuing on, upon a successful login, the user will be shown a list of courses he or she is currently enlisted in, and the user will then be prompted to select the course they want to continue to. At this stage, the client, being the application, will make a request for student data based on the selected class, and the backend will determine whether that user is a student or instructor, and that will allow the application to transition to the appropriate user interface. More on that later. Upon a successful response from the backend, the student data will be parsed, and statistics such as the average, standard deviation, minimum to maximum per category or assignment in that category will be calculated, and the resulting data set will be stored into an XML file so that the front end can access and display and plot the appropriate charts. Additionally, the XML file will be cleared upon a user logout to ensure that no sensitive data is left over after a user session is ended.
Now I'll tell you a little bit about the front end. So once the data is stored on the iPad, we have to manipulate it to create the front end so that it can help us to reach our ultimate goal. We want it to be easy to use so that professors could evaluate a student's performance within seconds. In addition, we want it to be used primarily for inside of the classroom while professors are giving their lectures. For our technologies, our features were developed using HTML pages styled with CSS and JavaScript functions. These pages are displayed within a UI web view. We chose these technologies because of their responsiveness to styling, a large focus of our visual displays. I'll now walk you through the different features that we've developed. Here we have a generic lecture hall layout, which displays one of our most significant features, the heat map concept seating chart. As mentioned earlier, we focus on professors being able to evaluate student performance while giving their lectures. This feature gives the professor an idea of student performance with a simple glance as they are teaching. Students are able to log into a seat, and the professor is able to view what essentially becomes a live seating chart, letting them tailor their lectures to student performance. Each seat displays the student's name and a color that corresponds to how they're performing in different subject categories within the class, relative to everybody else in the class. You can select the category from the drop-down menu at the top of the screen. As you can see from the bottom key, there are 4 possible different colors that a seed can be. One each for 1 standard deviation above and below the average, and then the 2 ranges between there, above and below average. To view more details about a student, the professor can click on a student's seat. Clicking on a seat brings up a more detailed view, which displays a student's performance on each assignment in each category, as again selected by a drop-down menu. The x-axis displays each assignment name, and the y-axis displays the score. The graph also displays the minimum and maximum scores achieved by the class. The box represents the range from 1 standard deviation above and below the average. And the score of the selected student is indicated by a red line. You can also tap in order to view more statistics about each assignment. We've also developed an overall performance graph, and this shows how a student is performing in each category of the class based on the percentage of points earned. While those graphs display how a student is performing relative to the entire class, we also have a feature so that a professor can group students together and compare them to each other. By selecting different students, they get to see the same charts, but this time they also get to highlight which student in order to see that student's specific data of the group selected. The last screen available to the professor allows them to change classes, log out, or clear all the seats in the classroom. The clear all the seats is important because it essentially allows for a clean slate class layout and essentially starts a new class. Now this brings us to our student side of the application. The student's able to see the same seating chart, but this time they just see a red seat if somebody else is sitting in the seat, but where they are currently logged in shows up in green. They're able to change their seat by clicking on any available seat. And finally, the students can see the graphs of their personal statistics, which also helps them to visually understand how they're performing against the rest of the class. That's the end of our presentation. Thank you for coming out. We feel that we've reached our goals, and now we'll take any questions you might have.
Questions?
How hard is the initial setup for a professor, whoever would be doing it, and are all students in?
It's connected to Blackboard, so that's one of our goals. We didn't want to give them any extra hassle, so they're just simply entering the grades as they normally would, and then it's calculating all of it for them. So no calculations necessary for them, nothing added.
So you depend on the student to put in information regarding where they sit in class, right?
That's
Do you think
correct.
that'll be a problem? Do you think students will care enough to put in their seat information and keep that up to date?
That's what we kind of came up with the whole clear seats thing. So every time we're kind of hoping that if the professor encourages it, that they will log in upon entering the classroom, and going with the whole honesty policy, they'll put themselves in the right seat.
Is there any particular reason why you really focus on using C# on the front end and using Java on the back end?
Yeah.
We just use them because that's what we're most familiar with, I guess.
I know, as far as the front end, I felt as far as styling goes, I think it was really easy to make something really responsive in JavaScript and HTML pages as far as even creating the seating chart layout. So that's why I chose HTML, CSS, and JavaScript.
You mentioned how your use of Xamarin would make it, or Monotouch would make it easier to develop code that you can run on multiple platforms. How hard would it be if you wanted to make an Android version of this, or a Windows external version of this?
We haven't started doing that yet.
Yeah, I'm just wondering if you have any I guess since you're using Monotouch, do you feel like your code is portable onto different
Oh
devices?
yeah, I think it's
It'll be an easier task now.
Yeah, it's definitely portable, and I think also, yeah, it's definitely portable. Especially, we're using HTML, CSS, and JavaScript that should translate perfectly fine, so.
Not all classrooms are laid out the same, so you have the ability to change the seat layout.
Unfortunately, at this time, we have 2 classroom layouts on our application. Just the generic one that you saw, and then one for our customer, the studio classroom in which he teaches. So we developed that one, but right now, our features we have to actually create the classroom layout ourselves. But
Is that going to be something you add on as like a service that the user could do, or is that something that they have to like purchase from you, the like a specific classroom layout?
I guess that's something that the user would have to put in the application.
So now that you have a connection to Blackboard, I presume you'll be able to pull in all sorts of data and other artifacts such as assignments if you needed to, right? So like, for example, in a future version, what I could do is I click on a student and then see like all the assignments that they've submitted. If you have that ability to connect to Blackboard.
that would be possible.
Are there any, so I'm curious, how would your architecture scale if you had to support multiple classes or multiple different?
Unfortunately, Blackboard Web Services doesn't really provide much documentation about how their web service scales, so we've only tested with a few iPads, so we're not sure of how it would scale up to hundreds of users.
All right, thank you.